So welcome again in 2025, and your choice to stick to this channel and to Python will pay off. Let's just see where Python has gone over the period of time. You'll see starting early 2021 right up to here, anyone who has picked up a career path in Python has made a big growth, and so will you. It's not going to be any different. Python has been doing so many fantastic things. It's an easy to use programming language, and it will provide you success. Today, those who deal with data and Python make about 120K US a year. This is not too bad, right? And this again comes from the international records. See, 2024 and 2025 is not yet come because the year is not over. Soon you will see how good your career will turn. Going back, last time around, we saw a simple Pandas script. Pandas, like I was telling you, was a great tool to break through into data. If you are a Python programmer, whether you are a web developer or a data engineer or data scientist, data is in your face. Whether you're picking it up from your database, a file, or any other repository like a memory location. Right? For performance reasons, you might just simply be reading off a memory or a cache for just quicker gets so that your data gets analyzed faster. Now, coming back to our today's session. Last time we saw a simple read of data. Let's just go back in there and see what we did. So we saw this file, name, age, address of these 3 or 4 people getting dropped on your screen, right? The first row being the column names, and the second being the second set, which is this is known as the metadata as to what those columns are, and what is coming below as the name, age, and the address of these people. That was a fairly simple way to pull data, right? Now, for those of you who are thinking, now what if I have another file? All you have to do is write a similar code, which is PD. We have imported pandas here as PD, and we are asking PD or pandas to read a CSV file. Let's just, and here we are going to display that, right? Right. There are several ways to do this. Let's just keep it within our skill set for now. So Pandas is essentially giving us a data string for everything that we have done. So if you'll notice, there is considerably more data than your 3 rows, and you really did not have to write a for loop to read data in. So now your job of reading data is available to you as single command. Isn't that great, right? For those of you who've been struggling to read and then you've been writing lots of loops to read through that, this is one way to avoid it. So somebody gives your data and you want to do a visualization of that, or say you want to import that data back into your database for some purposes. This would be a good tool. Let's just do one more of these. And I'm going to do something weird, and then I'll explain what that is. So here I've asked you to read customers and raw orders, and then we ultimately print it. It's taking its own sweet time. So with pandas, everything goes right into the resource given it to it, which is the memory which you've asked it to read right now. There are other ways to split this up into pieces. So as you can see, it will go through 2 rounds of printing because I ran it twice. So that's one thing you have to be very careful with when you're running Visual Studio Code and you have lots of data. There is a time delay between the time you make the request to its actual running. Depending on the size of the data, it may take a little longer, so be patient. So as you can see, this is doing its job, right? But there's another funny thing which is happening, and that is I've got two objects by the same name and still printing away to glory, right? So it's going to do the same thing all over again. Let's just be patient. But while that is happening, it means what I mean to show you is Python really doesn't care if you overwrite your data read. So you have to be extremely careful. So to make things simple, I've seen DF is good for programming when you're learning, but make it something more sensible. For example, like you could make it as DF customers, right? CUSTS, and if this is orders, you guessed that right, DF orders, right? And then DF obviously has now disappeared, so you make it as DF orders, right? Now the DF tells you that it's a data frame, and this second part of it tells you what it actually is meant to be storing, in this case orders. Now we have got two objects in our code. The question is, how are orders and customers connected? There has to be a connection, correct? So if you go on Amazon or your eBay or your favorite e-commerce site and you sign up, you actually are becoming a customer. And when you read the data, you will realize that the data is from the system is actually what orders you gave apart from the product catalog, right? We have got the product catalog here, down here. We'll talk about that. So the scenario here is e-commerce. All of us would be familiar with the e-commerce story, right? So our journey, the journey we are taking is that we are looking at data from an e-commerce company, and some of it we are trying to understand how it is set up. So the two runs are done. So it takes a little bit of time to read that amount of data. Nothing to worry. But if you go into raw orders, you will notice in the first row, as we call it, the metadata, the ID, which is the unique identifier. The format here you're seeing, right? It's a mix of alphabets and numbers. These are all hexadecimal, separated by hyphen. This is a format known as UUID. That is a UUID. And here you have the ID, the customer, which is your reference. This is how an e-commerce will actually look at you. It's your ID. If you are a student, it's like your roll number or your registration number for an exam, right? So a single customer may have ordered multiple things, right? The ID, the customer, and ordered at. You see, the ordered at is the time, and the subtotal for it, all right? The store ID, the subtotal. For example, Amazon, you're purchasing from Amazon, you must have purchased for, say, from Amazon UK, and then that's a different storefront really. The tax rules and everything is different out there. So, which is different from the US, which is different from India, which is different from any other country, because each of these countries have got their own laws for taxation. That apart, let's come back and understand this. Now that we saw there is something known as the customer, right? Now, if you go to the raw orders, it has the customer, and raw customers are identified here by a ID, which is similar to what you saw here, right? This column. Right now, let's just try to. There you go. So you have identified Mr. William Wang, who is in the customer database, who is who has actually placed an order into your order system. And here you can see he has placed multiple orders, right? It's not just he who has placed orders, but there are multiple customers who have placed orders, right? Now, the next job would be the most fundamental job is to find out which customer gave which orders, right? So how are they connected? Like we saw, they are connected by the customer ID in both in the customer CSV and the raw orders CSV. Now let's quickly jump and look at some kind of documentation. The Pandas data frame has this method called join, right? And I'll show you something very interesting here. Here the syntax is df.join. The df.join will join with the other data frame. It's like customer and orders, the left suffix and the r suffix or the right suffix. L and r are left and right. So if you see the key or the what is the common part would be understand. See, there is the key. Both of them are called key because if you see here there is a key and here there is a key, like we have the customer in our scenario. So this is going to be key caller and key other by prefixing underscore caller and underscore other. The underscore caller is here and underscore other is here. So that way you can identify which column is being shown, and then you can look at both and say whether this makes sense, right? So what we have done is we have incorporated the same code which we just saw earlier on the Pandas documentation with the join command into our code. So dfcus being the first data frame we took, put it here, and we said dfcus.join, which means correlate the data with orders, and anything which comes with this is common, you prefix it with cust, or as people prefer, with an underscore cast, and then store this into a new data frame. So now in this process, we are not only correlating, the result of this operation is a new data frame. Like you had a new data frame when you invoked the read CSV, the join gives you a new data frame. And let's just quickly run this by hitting the play button. And let's wait for the results. So as you see, there are results which have come out for the data frame which you joined, right? So now the join operation has been performed for you, and our next step is to look at how to save this new data frame into a file. Let's do that in a moment. So for this effort, we are looking at the Pandas documentation again. Like we had read CSV, we have a to CSV, right? And what the to CSV does is, given the data frame, you call the method to CSV, name the file, and say for index is false. For now, it just creates a running serial number. But since we have got our customer IDs and the customer and the product IDs, etc., the order IDs, we do not require an additional index. But so we can say index is equal to false, right? So what we are going to do is we are going to pretty much copy this code, right? I'll just show you how easy that is into our code, and Let's do the simplest thing which Microsoft has taught us, write, and I'm going to write CSV. Eventually it should turn up on a side pane. I am going to run this now, and like we did last time around, our job would be to just hit the play button. It will take a little longer than last time, but if you see, it has created an out.csv, and it has generated a file which gives me a bunch of information around what has been correlated. All right, now we are back with another session, or the continuation of the previous session. So I'm sure you have run your code this far and experimented, but if not, just stick around and look at this part. Right, so we did a join earlier, right? And this time we're going to add something else to the code called merge. Well, to connect that customer to the order, the program really needs to be told how it can connect, and we did not tell it how to connect. But nonetheless, Pandas did join that, and it gave us an out.csv, which is, to tell you the truth, a blatant set of lies regarding the orders. And I'll explain why. Like I said, this join does not know how it should do the join. But then how did it join? It built what is known as indices, and then used indices to join both. So those are not really good. And if you know, and if you remember, the customers whom we talked about a little earlier, the raw customers, had a field called ID which uniquely identified them. For example, there can be a million Amy Lees, or Johnny Hughes, or Amy Diaz, right? But how do you uniquely identify that person? That is this ID. And if you go back to orders, it simply has to identify by that. And if you go to the beginning of that, let's jump there, it tries to identify by a customer, right? So it's called customer here. Now, how do you tell in one table the customer is a field, and in another CSV file which you're looking at, it's known as ID? If you saw the customer, it's an ID, right? In the database parlance, each of the stores or the CSV files will be known as tables, and in the case of the metadata, they would be known as columns, as they are like in Excel. But let's just go back to what we're talking about. You're saying, we were asking this question, how can we correlate it? In which case, that intelligence will have to be provided by us using the pd.merge command. And I'm going to merge dfcus and dforders using a join mechanism known as inner. For now, just copy the string. It primarily means get me all which I can correlate between these two, and ignore the ones which I cannot. Right? If a customer has not placed an order, just ignore him. I don't want to know about him. Primarily, when you're looking at analytics as to who is the customer who has made most orders, should he be given a discount code, or should he be celebrated for making so many orders? Those are the kind of things which you're looking for in this scenario, right? And you're saying on the left, on the customer side, there is ID, which we saw a little earlier, ID, and on the right, which is the orders, we have customer, and that's what we have told here. and we run this. Note this is going to take a lot longer to work, as the proper join or the proper correlation has been specified here. Now, as we specify that, and then we write this out to a new file known as output proper to differentiate the data, right? So that we have out.csv and out proper.csv. It's going to take a little time for this to do its job. Let's be patient. You may see an odd notification saying that it's running laggy. Just stick in there and we'll talk about it. So it's going to take its own time. The reason being there is more data this time and it needs to correlate. Last time, if you remember, when we ran it, it sort of finished rather quickly and it's just printing out this correlated data. It's just going to take its time. So like we were saying, this correlation is going to take its own sweet time. While if you go to the orders CSV, like I said, it's going to take time because there is more data. Now, if you are wondering where you can get this data, I will link these data files into your video comments so that you can look at that and pick up the data. So give it a minute again. And as you can see here it says ID X and ID Y because the left and right, the merge has created it. It says Amy Lee, and Amy Lee has created so many orders. Now, if you look at the old CSV, it was completely different, right? So it sort of messed up a lot of things. So in the event, your original columns are named differently, and you do not want to join by the indices, the running order from row 1 to n. What you do want to do is to use the merge functionality which is provided so that you can correlate them. If you are coming from the database world, this would be your reflex action. Don't use this. Use this in that kind of a scenario. But you still need to know how you can correlate indice to indice. Sometimes that may also be the truth. All right. So, for example, two tables having one not having a uniquely identifiable row but has got, say, student marks or something like that, you could still be doing something like this, like the join, that is. But if you have this kind of a scenario, you could use the merge, and depending on the join, you are saying what should be the left column. The customer I connected on the ID column because this is the customer's unique ID, and on the order, the customer column actually had the customer ID, so we mentioned the column as customer. If you see the raw orders, the customer column had the customer's ID, right? ID and customer, the second column after the comma. The CSV has got the comma separated values here, and we are reading them out now into a proper file. Now you have got this new stage. Now you do not have to reprocess all this, you just have to read it off this time, next time, right? So you can practically, let me just comment this out for a faster run. I'm going to comment all of these. A little neat trick in VS Code is control / or command / on Mac will cause the code to get commented, right? So what we are going to do next is df odds odds is equal to read CSV, like we saw here. But where did the read CSV come from? It came from the Pandas library, which we call pd.read CSV. And what is the file you want to read? It is the out underscore proper dot CSV. I'll comment this out. I'll avoid the printing on the screen and save a little time. So let's run this. I'll close those files out to give my computer a little bit more memory for it to run efficiently. So it doesn't like something. What is that? It says, I put a comma instead, and it's telling me, hey, what on earth are you doing? And there you go. We are running it. It's reading. It will show you no output because we are not asked it for any output. And as you know, the program terminated. Has come back to the terminal just for the hell of it. Yeah, I'm not going to do that. I'm going to say done. All right. Yeah, for the heck of it, I've got the done string in there. Now you know that the program has completed that and it's executed. So what you're seeing so far is using the Pandas library to import data, to correlate with join and merge. Merge being more database like, specifying left, right, called tables, and we did it right off the Pandas library like we did for the join, and then we created the output files, in our case out.csv and outproper.csv. The outproper.csv had better results because of the way data was organized, and we could specify the left and right columns to join on and the data frames to work against. That was what we covered. Try this out. I'll be sharing the data links for these files, and try it out and let me know how you like. Comment and share with your friends if you think this has been useful, and all the very best.